When we're solving exponential equations, the first trick that we have is to try to make the bases match. So we have 5 to the x equals 1 over 125. So if we could change that right side into a base 5, that would be ideal. And some of you can probably see what's going to happen immediately. So I need to change that into a base 5. You might think of this as 125 to the negative first. But I know 125 is 5 to the third, so really that's like 5 to the third to the negative first, or multiply your exponents, that's 5 to the negative third. If you can jump straight there, be my guest and do that. 1 over 125 is equal to 5 to the negative third. So once you get to a point like right here where your bases match, really the 5s are just going to knock each other out. And it has to do with logarithms, which we'll get into later, but the 5s knock each other out, and you're left with x equals negative 3. So the whole key to the whole ball game is to make the bases match there. So in example 5, we know that 9 is 3 squared. So we would have 3 to the x plus 1 equals 3 squared to the x minus 3. We multiply the exponents there, so distributive property, 3 to the x plus 1 equals 3 to the 2x minus 6. And so again, once you get to this point where the bases match, your bases are going to cancel each other out. X plus 1 equals 2x minus 6. We set the exponents equal to each other, and then we're going to solve. So subtract this x over, add this 6 over, x equals 7. So example 6, the hardest one, x to the 2/3 power equals 25. Okay, so we're not going to be able to make the bases match in this case because the base is the variable. And so what we're going to have to do is isolate. If you've got one variable to solve for, we can usually isolate. And so I think if you think about this as x to the 2/3, my first instinct was to raise both sides to the 3/2 power. That's probably the most efficient way to do it, but you have to really know what you're doing. So I'm going to show you a little bit longer way that I think will make a little bit more sense maybe of what's happening. So I'm going to do it in 2 steps instead of just 1. So I'm going to raise both sides to the 3rd power. And so the 3's are going to cancel out, leaving with x squared equals whatever 25 to the 3rd power is. I could get out a calculator and find that, but I don't really need to. We should know how to solve this at this point. If we're going to solve this equation, we're going to take the square root of both sides. So square root both sides. You have to remember plus or minus, though. That's kind of the trick that I think you would forget if you did it the other way. So we have x equals plus or minus square root of 25 to the 3rd. And that just so happens to be the same thing as plus or minus square root of 25 to the 3rd. Okay, so inside the square root or outside the square root, that 3 is doing the same thing. And so I think in the red, it's a little easier to see that the square root of 25 is going to be 5. We can do plus or minus 5 to the 3rd power. And so, of course, that's going to equal plus or minus 125. So if we go back and we try to do it the other way, you can still do it the other way. These 3's cancel, the 2's cancel, and you're left with x equals plus or minus 25 to the 3/2. Okay, and so the plus or minus is the thing. When we are taking a 1/2 power right here, that's the same thing as when we took this square root over here. So we're taking that 1/2 power, we're taking that square root, and that's why you have to do the plus or minus. So it's going to turn into the same thing. Square root or half root of 25 is 5, and then to the 3rd, you're going to get the same exact answer. Compound interest. If P dollars are deposited in an account paying an annual interest rate of R compounded N times a year, then after T years, the account will contain A dollars. So we've got this formula. You're going to want to have this formula handy, but you're also going to want to know what these letters are talking about. A is the final amount, and P is the principal or starting amount. R, of course, is the rate, the interest rate, and N is the number of times it compounds. And so T is in years, R is rate, and T is years. Okay, so knowing those letters is going to make these problems pretty much just plug and chug. So when we see example 7, $2,500 is deposited. That's how much we started with. In an account paying 3%, that's the rate, per year, compounded semi-annually. That's the word that's going to tell you N. And in this case, they're telling you N equals 2 for twice per year or semi-annually. Part A says find the amount in the account. And so we're finding the amount. That means the final amount is our variable in the account after 10 years with no withdrawals. So we're just using that formula and plugging in the numbers. So we're finding A equals, the principal is 2,500 times 1 plus the rate. You have to change to a decimal number, so 3% is 0.03. If you don't do that, you're going to get it wrong. Over N, which was the number of times it's compounded, to the, I always switch it and say N times T, but it doesn't really matter. 2 times 10 years. 2 times 10, 10 times 2, either way. So you're going to want a calculator. You plug that in, and I've already done that. 2,500 times 1 plus 0.03 over 2 to the 20th power is what that's going to be. If you don't use parentheses correctly, you're not going to get the right answer, but it looks like 3,367 and 14 cents. $3,367.14. So part B says how much interest is earned over the 10-year period. So if you think about it, we've ended up with 3,367 and 14, but we started with 2,500. So the interest is just going to be that difference. Interest equals how much we ended with minus how much we started with. So let's subtract 2,500, 867.14.